Landing on Mars is a one-way ticket. This isn't fear-mongering, it's a reality NASA officially acknowledges. A round trip to Mars takes 900 days. What does that mean? You're stuck in a cramped spacecraft for 2.5 years. Worse than prison. Even scarier, Mars radiation is 20 to 40 times higher than Earth's. No magnetic field protection. Your body gets blasted by cosmic rays every day. In just 6 months, the radiation dose you absorb equals 1,800 to 3,000 chest X-rays. And that's not even the deadliest part. Mars' gravity is only 38% of Earth's. Stay a year and your bones lose 10% to 20% of their calcium. Muscles atrophy 20% to 30%. Back on Earth, you might not even be able to stand. The wildest part? Sending a message from Mars to Earth can take up to 44 minutes for a reply. If oxygen leaks or life support fails, people on Earth can only watch live and can't save you. Even more mind-blowing, Elon Musk plans before 2050 to send 1 million people to a Mars fleet colony. They might never come back. Today we'll look at the chilling truths behind human Mars colonization plans. Why are humans still desperate to go to Mars? The answer lies in February 18, 2021, the moment Perseverance rover successfully landed. NASA chose Jezero Crater for landing. This decision rewrote our understanding of Mars. Because 3.5 billion years ago, this was a massive lake. Scientists using orbital satellites found the lake was 45 kilometers wide and over 250 meters deep. Even more shocking, on the west side there's a complete river delta, proof rivers flowed into the lake continuously for at least millions of years. On Earth, any place with long-term liquid water has life. Scientists picked Jezero Crater to bet on one possibility. If Mars ever had life, their fossils are definitely buried in this ancient lake bed. That bet paid off in July 2024. Humans may have found signs of Martian life. July 2024, Perseverance in a rock from Jezero Crater discovered evidence that thrilled the global scientific community. This rock, named Cheyava Falls, came from an ancient riverbed. When scientists analyzed it with high-res cameras, they found many oddly colored spots on the surface. Further spectral analysis showed these spots contain 2 key minerals, leopardite and arsenopyrite. On Earth, these 2 minerals almost always appear together only where there's microbial activity. Leopardite forms during organic decomposition. It's found in Earth's peat bogs, swamps, and fossil layers. Arsenopyrite is even more special, a byproduct of certain anaerobic microbes. Of course, rigorous science must rule out all possibilities. In theory, under extreme heat or strong acid, these minerals could form abiotically. But the key is detailed analysis of the rock showed no signs of high heat or strong acid environments. So what does this mean? By Occam's razor, the simplest explanation is usually correct. These minerals are traces left by microbial activity. Even more exciting, this rock is about 2.3 billion years old, much later than scientists previously predicted for Martian life extinction, meaning Mars's habitable environment lasted longer than we thought. How did Mars go from habitable planet to dead desert? To understand, we go back 3.6 billion years. Mars then was very similar to Earth today. It had a thick atmosphere, mostly carbon dioxide and nitrogen. Atmospheric pressure nearly half Earth's. Surface temperatures fluctuated between -4 degrees Fahrenheit and 68 degrees Fahrenheit. Liquid water could exist stably. Analysis of Martian meteorites shows Mars had a strong global magnetic field, about 20% of Earth's today. This field acted like a shield blocking direct solar wind blasts. But around 3.2 billion years ago, disaster struck. Mars's core began cooling. Molten liquid iron solidified. No more liquid iron flow means no magnetic field. Mars's field weakened rapidly over millions of years and eventually vanished. Without protection, solar wind hammered the atmosphere directly. Every second, tons of atmospheric molecules were stripped away and lost to space. This went on for hundreds of millions of years. The atmosphere grew thinner and thinner. NASA's MAVEN probe observed from 2015 to 2023 that even today, Mars still loses about 100 grams of atmosphere per second. Over billions of years, this loss is fatal. When pressure drops low enough, liquid water can't exist. All lakes and rivers evaporated or froze fast. Water vapor was blown into space by solar wind. Ice sublimated and vanished. Eventually, Mars became what it is today. Atmospheric pressure 0.6% of Earth's. Average temperature -81 degrees Fahrenheit. Surface barren and lifeless. Could Earth follow Mars's fate? That's an unsettling question. Monitoring at global geomagnetic stations shows Earth's magnetic field strength has clearly declined over the past 180 years. In the South Atlantic, there's a special zone called satellites flying through it often malfunction because cosmic rays penetrate the shield easier and hit electronic components. Every time the ISS passes this zone, astronauts get noticeably higher radiation doses. Even more worrying, paleomagnetic records show Earth's field flips completely every 200,000 to 300,000 years. North and South poles swap. The last flip was 780,000 years ago. By that cycle, the next one is overdue. During a flip, field strength drops sharply, possibly to 10% of normal. The process lasts thousands of years. It won't lose the field completely like Mars, but the impact on human civilization would still be huge. Satellites could fail, communications go down, atmosphere eroded more by solar wind. This is why studying Mars matters so much to us. Mars isn't the future. It's a mirror for Earth, showing risks we might face. Mars's subsurface might still harbor living life. In July 2018, ESA's Mars Express probe made a stunning discovery. Radar detected a huge liquid water lake 1.5 kilometers under the South Pole. The lake is about 20 kilometers long, covering the area of 100 football fields. More importantly, it's not ice. It's real liquid water. You might wonder how water stays liquid when the surface is so cold. Scientists believe the lake is full of salts, mostly perchlorates, dropping the freezing point way below pure water. It stays liquid even at -94 degrees Fahrenheit. Mars's subsurface geothermal heat keeps it warmer than the surface, around -22 degrees Fahrenheit in polar regions. On Earth, wherever there's liquid water, there's life. Under Antarctica's ice sheet, 3 kilometers down, scientists found a completely isolated ecosystem. Its microbes evolved alone for millions of years. In rock layers kilometers underground, they've also found microbial communities living off geothermal energy. So could Mars's underground lakes hide life too? From 2020 to 2024, scientists found 3 more similar underground lakes. This suggests Mars may have a full subsurface water system. If life is really there, it could have survived in the dark underground for billions of years, waiting for humans to find it. Human Mars plans are accelerating. In October 2024, NASA released its latest Mars exploration roadmap. According to the plan, in 2026, ESA and Roscosmos's ExoMars rover with a drill will land on Mars. It can drill 2 meters deep to sample for possible underground microbes. In 2028, NASA's Mars Sample Return Mission Phase 1 launches. A dedicated lander will touch down in Jezero Crater, collect all Perseverance samples, then rocket them to Mars orbit. In 2030, An uncrewed ship will grab the samples in orbit and return them to Earth. This will be humanity's first samples from another planet. SpaceX's timeline is even more aggressive. Musk announced 2026 for the first uncrewed Starship Mars landing test. If successful, 2028 sends the first astronauts to land on Mars. The goal? Build a self-sustaining Mars base by 2050 for 1 million people. Sounds like sci-fi, but breakthroughs are happening fast. Starship reusability is proven. Tech to turn subsurface ice into oxygen and rocket fuel is mature. We don't lack tech, just funding and resolve. Why become a multi-planet species? Not just to dodge Earth disasters, but for long-term human civilization survival. In the past 4.6 billion years, Earth suffered 5 mass extinctions. The latest, 66 million years ago, wiped out dinosaurs via asteroid impact. Scientists estimate asteroids over 10 kilometers wide hit Earth roughly every 100 million years. Besides asteroids, there are supervolcanoes, supernovae, gamma-ray bursts, countless threats that could end civilization. Anyone could do it. But with an independent Mars colony, even if Earth faces catastrophe, humanity won't vanish completely. Mars humans could preserve our knowledge, culture, and tech, wait for Earth to recover, or push farther into the stars. More importantly, exploring Mars will spawn countless tech breakthroughs. Life support, radiation shielding, closed-loop ecosystems, AI, all feeding back to improve life on Earth. Those choosing Mars. In 2013, the Mars One project got 200,000 applicants for the first Mars settlers. Though it failed due to funding, their stories are moving. A 78-year-old retired engineer said, "My biggest regret is not seeing humans land on Mars. If I could, even live just one day there, I'd go." A 32-year-old female doctor said, "I know I might never return, but contributing to humanity's future matters more than anything." These aren't crazies. They're true pioneers, like those 500 years ago who risked their lives sailing to explore new continents. They knew the dangers but chose to push forward. Every leap in civilization was driven by risk-takers like them. Without them, we'd still be in caves, ignorant of the stars. Mars is humanity's mirror and our hope. As perseverance slowly rolls across Mars, every photo and data point tells a story of life, civilization, and the future. Mars shows us even a planet with oceans, atmosphere, and magnetic field can turn to desert in billions of years. It warns us to cherish Earth, protect our only home, for now. But Mars also gives hope. Those minerals in the rocks, those underground lakes, they tell us life is tougher than we imagine. The universe more wondrous. Maybe soon, when the first humans build a base on Mars, plant the first crop, breathe oxygen they made, they'll look up at that blue planet in the night sky and realize humanity is no longer trapped on a single world. Our journey is the stars and seas, and Mars is just the first stop. They'll look up at that blue planet in the night sky and realize humanity is no longer trapped on one planet. Our journey is the sea of stars, and Mars is just the first stop.